All right, for number 19 through 24, we are still solving for the indicated values. It says assume that lines that appear to be tangent are tangent. And so in number 19, the first thing I notice is that I have a quadrilateral inscribed on a circle. And so we know that we learned a theorem that says that the opposite angles in a quadrilateral inscribed on a circle are going to be supplementary. And so that means that this 87 is going to be supplementary to A. So we know that A plus 87 should have a sum of 180. And so when I do that math, I end up getting that A is 93 degrees. So those should be supplementary. Okay, so I'm going to go ahead and fill that in the picture too. This is going to be a 93 degree angle. If I wanted to find the other angle, I could to find what's missing for this little piece. But since they didn't ask me for it, I'm not going to use that one as of now. We might come back to it. Okay, then I notice that I have a 78 degree angle here that is inscribed. So how do I find the arc that opens up to? I'm going to do 78 times 2. And so when I do 78 times 2, that will give me this whole thing. So what is 78 times 2? 78 times 2 is going to give me 156. And so B is going to be equal to 156 minus 36. 156 minus 36 is going to give me a sum of 120 for B. B is going to be 120 degrees. Okay, and then last but not least, we want to find C. So where is C? C is right here. The first thing I see is that I've got an inscribed angle opening up to that. And so how do I find that full green amount from here all the way around to here? I'm going to do 93 times 2. When I do 93 times 2, I get 186. And so we just want this part for C. So I'm going to do 186. C is going to be equal to 186 minus that 36. 186 minus 36 is going to give me 150. Okay, so we had to use some inscribed angles and then some subtraction of those angles that were, we had our inscribed angles, then we had our intercepted arcs. And so this 36 had to be subtracted off of each of those. That was kind of the key to this problem. But again, multiple ways that you could do it. All right, the next thing I see on this first problem, on number 20, is that I have two secants intersecting, which are creating some angles. Remember that we learned a theorem about these angles. We learned that this angle is going to be equal to the sum of these two arcs. So I'm going to go ahead and do that in colors real quick. We know that this angle, angle X, is going to be equal to the sum of the arcs. So that is going to be an arc plus the arc divided by 2. So X is going to be arc plus arc, because they intersect in the middle, divided by 2. So let's go ahead and fill that in. X is going to be equal to 86 degrees plus 88 degrees divided by 2. We know that that is going to give us, for that angle, that is going to give us an 87 degree angle. That is the average of those two arcs. If that's 87 degrees, how does that help me find Y? Well, together those make a linear pair, 180. So if that makes 180, then 180 minus 87 is going to give me 93 degrees, because those make a linear pair in the middle. Okay, so we found this angle first, this pink angle, and then we use that pink angle to find Y. Okay, now I have in number 21, I have a secant line intersecting a tangent line on the outside of the circle. So we did learn a relationship about that angle as well. Let's go ahead and call that X. We learned that when they intersect on the outside of the circle, we learned that that X is going to be equal to that big arc minus that small arc divided by 2. So let's change colors. That big arc minus the small arc divided by 2. So let's go ahead and write that. X is going to be equal to the big arc, the big intercepted arc from here to here, 120. Big arc minus the smaller intercepted arc divided by 2. And notice it's minus because they intersect on the outside. So X is going to be equal to 120 minus 60 degrees divided by 2. That is going to give me a 30 degree angle for X, or that question mark. So that is just one of the theorems that we learned. That's one of our formulas we need to know for our test. Number 22 is very similar to that, but instead of it being two secant lines, this is two tangent lines. Why is that significant? Remember that when you have two tangent lines, that creates two pieces of the circle, the pink part of the circle and the yellow part of the circle. So it's still the same formula, angle D. That angle D is going to be equal to that big arc, which is in pink, minus that small arc, which is in yellow. They're intersecting on the outside, that's why it's minus, and then that's divided by 2. So what do we know angle D is? Angle D is 67 degrees. We actually are given the angle. That's this piece right here. That is going to be equal to the big arc. Well, I don't know what the big arc is, and I don't know what the small arc is. But I'm going to put an X right here for this question mark, which means that the rest of the circle, this is where it gets a little bit complicated, we have to write an expression for that. Whatever it is, it's going to be 360 minus what I used for X. So that's going to be 360 minus X for this expression. Okay, so I'm going to take that big arc, 360 minus X. I'm going to subtract the smaller arc, which is X, and I'm going to divide that by 2. Whenever we want to solve for X, we're going to get the 2 to the other side by multiplying by 2 on both sides, and I get 134 equals 360 minus 2X. Negative X minus X is going to be negative 2X. So I'm going to do 134 minus 360. 134 minus 360 is going to give me negative 226 equals negative 2X. And I'm going to divide that by negative 2, and I'm going to get positive 113 for X. X is 113 degrees. If I wanted to find the pink arc, I now could by doing 360 minus 113. But that's all they asked me to solve for is the question mark. And I knew that this was if you were to create a radius here, this would be tangent, and then this would be tangent as well. Okay, so we did the big arc minus the small arc divided by 2. Okay, but now in this next problem, I have 2 secants that are intersecting on the inside of the circle, where we are given the angle, the interior angle, and we know that that angle is going to be a sum of the 2 intersected arcs. So I'm going to put an X here. So know that that angle is going to be the arcs added together. So the arcs added together, the intersected arcs added together, divided by 2. So let's fill that in. 108 degrees is going to be equal to 71 plus X over 2. We're going to multiply 108 by 2 to get the 2 to the other side. So 216 equals 71 plus X, and you're going to do minus 71 on both sides, and you're going to get X is 145 degrees. 145 is what X is equal to. All right. This last problem, we have we have a secant that is intersecting a tangent, and so that is going to create a big arc, which is what I'm looking for. I'm going to call that X. I have a question mark there. I'm going to put an X there. And then it has a small arc, which is going to be this piece right here. And so we know that that formula is going to be that angle on the outside, that star angle, is going to be equal to the big arc minus the small arc divided by 2. So what is that angle? That angle is 57. We're looking for the big arc. So I'm going to do X minus the small arc, which is 76, divided by 2. Again, to get the 2 to the other side, we're going to multiply by 2 on both sides. So we get 114 equals X minus 76, and we're going to add 76 to both sides. And when we do that, we get 190 degrees for this major arc, which is what we were looking for. And I will start a new video for the next few problems.